Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, in this video, we will continue our discussion on exercise 3 for per unit system. Okay, look at to exercise 3. Okay, the question is draw an impedance diagram for the electric power system shown in figure 9. Okay, this is a figure 9, which is we have a one line diagram. Okay, we have a generator G1, we have a G2, generator 2, transformer 1, line, transmission line. From bus 1 to bus 2. Okay, and then this is transformer 2. Okay, showing all impedances in per unit. Okay, all impedances in per unit on a 100 MVA base. Okay, so choose 20 kilovolt as the voltage base for the generator. Okay, you can choose 20 kilovolt for V base for generator. Okay, the three phase power and line to line rating. Okay, this is a line to line rating are given below. Okay, for example, this is a voltage 20 kilovolt for a generator. This is a line to line voltage. Okay, this is the apparent power of the generator 1. Okay, equal to, and then X equal to reactance of the generator 1. Okay, which is equal to 9% or equal to 0.09. Okay, 0.09 per unit. Okay, 9 over 100. Okay, and then this is the single line diagram. So the question is, you need to draw the impedance diagram, and then you need to show all the impedance in per unit. Okay, now you have you need to show all the impedances in per unit. Okay, based on S base equal to 100 MVA. So now you have the per unit value. For example, G1. Okay, this X equal to 0.09, which is based on the value of 20 kilovolt and 90 megavolt ampere. Okay, for example, transformer 2. Okay, you have X per unit for transformer transformer 1. You have a reactance of the transformer 1, which is 16%, which is equal to 0.116 per unit. Okay, this value basically actually is based on this voltage and this apparent power. Okay, similarly to T2, G2, okay, line and loads. Okay, so the question is, you need to refer to the 100 MVA base. Okay, to the common S base. We call it S base new. Okay, so first of all, what you need to do, okay, so you need to redraw your single line diagram. You have a G1, you have a T1, you have a line, T2, and G2. And then you need to determine the S base. Okay, in this case, you need to consider S base equal to 100 MVA. Okay, but since you have a transformer T1 and T2, so you have to determine base for the primary side or low voltage side and high voltage side. Okay, for the both transformer for T1 and T2. Okay, let's say the base V base G1. Okay, V base for generator 1 equal to, this is your generator 1. We choose 20 kilovolt. Okay, 20 kilovolt. So based on its high voltage side for the transformer 1, we call it VB1 equal to 200 kilovolt. How to determine the voltage? You need to apply the ratio, okay, turn ratio, because we have a V base V1 over V2 of the transformer equal to N1 over N2. In this case, N1 over N2 equal to 20 over 200 kilovolt. Okay, so by using this ratio, okay, V base 1 equal to 20 times 200 over 20. Okay, so your base value of the secondary side of the transformer T1 equal to 200 kilovolt. Okay, so this base value, okay, at the secondary side of the T1 equal to the base value of the primary side of the transformer 2. Okay, this fix the base on the HV okay, of the T2. Okay, this is a high voltage. Okay, this is a primary side, which is we have a high voltage for the T2. Okay, because the turn ratio equal to 200 kilovolt at the primary, and secondary equal to 20 kilovolt. Okay, so at the high voltage, so base value equal to VB1. Okay, which means VB2 equal to VB1 equal to 200 kilovolt. Okay, but for the low voltage side, for the transformer 2, this is a low voltage side, you need to determine according to the turn ratio. Okay, V1 over V2 equal to N1 over N2. In this case, so V2 equal to V2 at the secondary side equal to N2 over N1, N2 over N1 times V1. Okay, so you will get 20 kilovolt. Okay, okay, so this is the base voltage of the system. Okay, before at the low voltage side, at the high voltage side of the T1, high voltage side of the T2, and low voltage side of the T2. Okay, so V base at the G2 equal to V base of the low voltage side of the T2 transformer 2. Okay, so next, since the question asks you to convert to determine the impedance in per unit based on S new, based on new apparent power, which is equal to 100 MVA. Okay, before this, our G, which is referred to 90 MVA. For example, our G2, our T2 transformer 2 refer to 80 MVA. So in this case, we need to refer to the common base. We need to refer to the common base. So how to transform? Okay, from old base to the new base. Okay, let's say if you want to determine impedance or reactance, okay, of the transformer and generator, you can use this general equation, which is X per unit new equal to X per unit old times S base new over S base old times V base old over V base new square. Okay, so in this case, for example, you need to determine X per unit new for the generator, which is X per unit old, which is 0.09. Okay, why 0.09? Because we have a 9%. Okay, equal to 0.09. Okay, times S base new equal to 100 mega divided 90 mega. Why 90? Because we have a old base value for the G1. Okay, 90. So times, in this case, V base old equal to V base new. Okay, V base old equal to 20 kilovolt. V base new at the generator side equal to this one, 20 volt. Okay, 20 over 20 equal to 1. So 1 square equal to 1. Okay, so then you can calculate X per unit new for generator 1. Okay, similarly for T1, okay, X per unit old times S base new over S base old times, okay, V base old over V base new. Okay, since in this case V base old equal to V base new. Okay, look at to the transformer. Transformer V base old equal to, at the secondary side, equal to 200k. So V base new for the high voltage side of the transformer 1 equal to 200 kilovolt. Okay, so sama same. So 200 over 200 equal to 1. Okay, similarly to T1 at T2, you can use the same equation. Okay, V base all equal to V base 1. Okay, since V base all equal to V base 1. Okay, similarly to G2. Okay, you can G2. Okay, what is the base value of the G2? Okay, G2 S base equal to 90 MVA and V base equal to 18 kilovolt, which is different by V base new. Okay, this is a V base old. So you need to use this formula. Okay, X per unit 0.09. Okay, 0.09. Okay, 9%, 0.09. Okay, S base new equal to 100 over 90. Okay, mega. So times by V base old. In this case, V base old is not equal to the V base new. So you need to consider V base old equal 18 equal to 18 kilovolt divided by 20 kilovolt. Okay, so square, then you can solve for the X per unit G2. Okay, so the base impedance for the transmission line, okay, equal to V base square over S base. V base square over S base. So then you can determine the per unit value, okay, which is equal, okay, X equal X actual divided by X base. Okay, you can get the per unit value of the line. Okay, then for the load, okay, the load impedance in ohms. Okay, load, we have information of voltage and S. From the S and the voltage, you can determine impedance because ZL equal to V line to line square divided by S conjugate, because S conjugate equal to V line to line square over ZL. Okay, then you can determine ZL. This is the actual value of the ZL. Okay, then you can determine the per unit value equal to, okay, Z actual divided by Z base. Okay, Z actual divided by Z base. So our Z base for the transmission of the transmission line equal to 400. Okay, is it clear? Okay, now you have the information of the per unit for all the elements. Then you can draw the per unit diagram. Okay, from the single line diagram, you can draw the per unit diagram. Okay, you can start from the generator 1. Okay, generator 1, we have a XG, okay, connected to the transformer. Okay, connected to the transformer. Then we have a load. Okay, we have a load. This is a load. Okay, we have a load. And then we have a transmission line. Okay, then connected to the common load, connected to the common, okay, or neutral. And then we have a line connected to the G2. And then G2, you have a reactance of the G2, and then connected to the source or EMF voltage. Okay, is it okay? Okay, so again I will repeat, okay, for the for this question. First of all, you need to determine all the per unit value for the XG for the transformer 1, transformer 2, and for the generator 2. And then you need to determine the per unit value for the transmission line. Okay, the last one, you need to determine the per unit value for the load. Okay, for the transmission line, you need to determine the base value of the transmission line, and then you can determine the per unit value of the transmission line. In this case, you have information of X of the transmission line. So X per unit of the line, you can determine according to this value. Sorry, this one equal to X actual, X per unit of the transmission line equal to X actual divided by Z base. Okay, this one is Z base, not X. This is a Z base. Okay, this is equal to Z base. Okay, X actual divided by Z base. Okay, X actual divided by Z base. Okay, all right. So for the load, now you have a load. So what is the information that you have for the load? Okay, load, you have a S and voltage. Then you can determine load impedance in ohms. Okay, ZL equal to V line to line square over S line conjugate. Okay, S line conjugate. Okay, S line conjugate. And then you can determine in per unit value. Okay, Z actual divided by Z base. Okay, in this case, Z base equal to Z base of the transmission line equal to 400 because they are in the same bus. Okay, they are in the same bus. Okay, then the last one, you need to draw the impedance diagram. Okay, I think that's all for this exercise. Okay, Assalamualaikum warahmatullahi wabarakatuh.